Hey guys, in this video I'm going to go over the second page of the review worksheet talking about limits. If you're looking at the limit as x approaches 0 or -3, a number, remember you can always try to just plug the number in. So I might just rewrite this for part A. Limit as x approaches 0 of, instead of f of x, let's write what the function is. It's x squared minus 5x minus 24 all over x plus 3. And I'm kind of looking at this that I could probably plug in 0. If I start to plug in zeros for the x's, this, and this are just going to disappear, and you're really going to be left with negative 24 over 3, which if you divide that out equals negative 8. And you can get your answer like that. So that one was pretty easy. Let's try the same thing with part B. First, I'd just like to rewrite it. Limit as x approaches -3 of f of x. Let's write what f of x is. X squared minus 5x minus 24 all over x plus 3. If you think about plugging in -3 there, if you plug it in the denominator, -3 plus 3, that's 0. You cannot have 0 on the bottom. So think we need to figure out another way. We said at the very beginning of the year when we started looking at limits that you could always try to factor and hopefully something will cancel. So let's try to factor the numerator here. If we do that, I'm going to keep the denominator x plus 3, but if we factor the numerator, x squared could be split into x and x. Then think about numbers that multiply to -24 but add to -5. How about 8 and 3, -8 plus 3? -8 times 3 is -24, and -8x plus 3x is -5x. That works, and you can see there's an x plus 3 on top and bottom. Those can cancel out, which is a really good sign, because now if we try to plug in -3 again, we'll get -3 minus a -8, which you can't see, but now you can. -3 minus -8, which is -11 for a final answer. Moving on to number 8, it says find the value of a so that the function below is continuous for all real numbers. We said that continuous means you can draw the graph without picking up your pencil. Or basically, if this is a piecewise function with two pieces, we want both of these pieces to meet. We want the limit from the left side to equal the limit from the right side. And they're going to meet at an x value of -1. So we need to set the limit as x approaches -1 from the left. 2x plus 4 is going to be that graph on the left. We want and that should be the limit as x approaches -1 from the left, or the negative side. We want that to equal the limit as x approaches -1 from the positive side, or the right side. And the graph on the right side is going to be ax squared minus 2. All right, so we said once you set it up, you have to show this limit notation to get points, but then you could plug in -1 for the x's. All right, make sure you only plug it in for the x's. So it's going to be 2 times -1 plus 4 equals a times -1 squared minus 2. And we can work on simplifying this and solving for a. So we're going to get -2 plus 4 over here. -1 squared is 1, so a times 1 is just a minus 2. If we do some simplifying, we're going to get 2 equals a minus 2, and then we can add 2 to both sides, and you get 4 equals a. And that's your final answer. Number 9 says superimpose the graph of the derivative function for the function on the graph below. So that just means we're given this function. Let's call this function f of x right here. Basically, we just have to graph the derivative. So we had some rules here when we were graphing the derivative. We said when f of x is increasing, that means the derivative is greater than 0, which means if we're talking about a graph, greater than 0 means it's going to be above the x-axis. That was a rule we talked about. Another one, we said if the original function f of x is decreasing, the derivative is going to be less than 0, or in other words, below the x-axis. All right, and then the other rule we talked about is that if it's neither increasing nor decreasing, it's going to be changing from one to the other. That means it's going to be a max or a min. In that case, the slope of the tangent line or the derivative f prime of x is going to be equal to 0, and that's going to look like an x-intercept on our derivative graph. So those are those rules we can use, and I always like to start at the mins and the maxes. All right, so if we look at this, try to zoom out a bit, I see a max right here and a min right here. Think on our derivative graph, those x values are going to turn into x-intercepts, we said. So just kind of follow it down to the x-axis. We should have an x-intercept there and maybe an x-intercept about here. All right, then we can trace the function to look at where is it increasing and decreasing. Trace it from left to right. It looks like it's increasing, decreasing in the middle, and then goes back to increasing. So on the left side, since we're increasing, that means on the left side of this x-intercept, if we're increasing, our derivative should be above the x-axis over here. So anything above, and again, I don't really know what it looks like. I'm just kind of guessing. Make sure it's above. Something like that would be correct. Then in the middle of this f of x graph, we were decreasing. Decreasing means our derivative is less than 0 or below the x-axis. So in between these x-intercepts, we should dip below the x-axis. Again, it's a sketch. I don't know how far below. It could go way down. It might just go a little bit down. We're just sketching. As long as it's below, you should be good. And then this last part was increasing. Increasing, we said, switches to above the x-axis. It should go above for the last part. So that green graph I would call f prime of x. That would be a sketch of our derivative graph. Again, a sketch. It may not be perfect. All right, so down here for number 10, it says the graph above is of the function f of x. It says use the power rule to find the derivative function, and then plot both on your calculator to compare how accurate your sketch was. So first we have to find the derivative f prime of x. We could do it with the power rule. We could take the exponent 3, bring it out in front. We'd get 3x squared minus 4. That's our derivative. And they want us to graph this original and this derivative we just found and basically compare what we get to this graph right here. Let's take a good look at that. I'm going to graph both of them on my calculator, and I'll show you what it looks like. Move this over a little bit. All right, so in y equals our original graph was x to the third minus, x to the third minus 4x. Our derivative that we just got was 3x squared minus 4. And we're just going to kind of compare the graphs we see. That's the original, and that's our derivative. I think we did a pretty good job. It looks like they dip a little bit lower, maybe like 1, 2, 3, -4, and I only went down to -1. I guess it would have been a little bit better if I made this dip a little bit lower in the middle, but other than that, the shape is pretty good. So I think I did a pretty good job. All right, that's it for the second page of this review. Hopefully you found it helpful.